Alright, I think I've promised you guys some kind of gnarly problems early in the semester, and 38 fits that description, and as does 37, which I'll do. We talk about um, exponential distributions here, and if you look at some of the charts, they show you um, what we're talking about there, and our problems themselves give you kind of decent examples of why and how this would be used. So we'll get into the work. And 37 says waiting times to receive food after placing an order at the local Subway sandwich shop follow an exponential distribution with a mean of 60 seconds. So my mean is 60 seconds. Calculate the probability a customer waits. I got A is less than 30 seconds. So we get in, and first, E we need to define. E, if you look on page 232, kind of towards the top, in that first paragraph, it says that E is just a mathematical constant. It's equal to 2.71828, not unlike pi, right? This is just kind of a mathematical constant that somebody somewhere derived that was way smarter than myself. And so we have E then, and our formula here is that the probability is equal to 1 minus E to the negative, I think that's called our exponential, times x being the number that we're looking for, in this case 30 seconds. Okay, so we come here and we do our math, and I'll try to do this over and hopefully I'll get it right, is equal to 1 minus our E, okay, and to the power, so we got to use our tent, right, our shift and our 6 key, and then a parentheses, and then a negative, and I got to click on this one. Okay, I just did the math. This one I've actually got entered as a text. Okay, so I got to click on that one, and times 30 is my x in this case, right, and parentheses, and hopefully that'll work. Yeah, I come up with a 39.35% chance. Oops, don't need that, but I could change it to that if I wanted to. Okay, and that would tell me that it's less than 30 seconds. Now, more than 120 seconds. Okay, I have to do the math the same way, but my math when I do this is always less than. Okay, and this is another case where the whole chart is equal to 1, right? And so when I'm going to do over 120 seconds, I do the math the same way. It's equal to 1 minus my E, and to the times, in this case 120, and hopefully I got everything right. I didn't. I screwed something up. Oh, it's to the negative, right? So I forgot to put a minus sign in there. Sorry. Okay, and this number has to be less than 1. So when I did that and I came up with a number bigger than 1, I knew I did something wrong. So keep that in mind, as you're going through yours and maybe picking things out. But again, now I'm looking for more than 120 seconds. Okay, and if the mean's 60, the odds that it's going to take more than 120 seconds, more than 2 minutes in that case, should be a little low. And yet I come up with an 86, and that's because I have to use the complement rule then, right? It's equal to 1 minus that particular one there. Okay, so I use the complement rule to get my correct answer, and then I go C. It says between 45 and 70 seconds. So now I have to do the 45, and so I do the formula the same. Okay, and then I do the formula for 75 as the same. Okay, and both of these are less than those numbers, so I should be able to just subtract one from the other. I got 45 minus 75, but I think I meant that that's supposed to be 45 to 75 seconds, so that 30-second interval between there, which is simply saying then that it's equal to this answer minus this answer. Okay. Again, the math done the same way. The last question gets really gnarly. Okay, and typically I've counted it for you guys. You have a similar question, and typically I've counted that as a bonus, so you know. But 50% of the patrons wait less than how many seconds? What is the median is basically what we're looking for. Okay, and that formula then is, and I don't have that written out, but it's up above, just up above the problem there in little blue. Okay, and it talks about what we're going to do here is using a natural log. Okay, and in this case the natural log that I'm looking for is a 50%. For you guys it's going to be 90%. Let's keep that in mind. You got to use 90.9, whereas mine's 50%. And so how do I do that? Well, the natural log is a function, and it's ln. Okay, so I come here. Oops, I'm gonna cancel that, and I'll delete this and start over, and hopefully I get this correct. Okay, and that's probably under math and trig would be my guess, as opposed to under stats. Okay, and it's this ln returns the natural logarithm of a number. Okay, and so let's click on that. There's probably other ways to do this, charts and those types of things, but yeah. Okay, I click OK. My number is 0.5, right? Your guys's will be 0.9, and so that gives me that number. Okay, then I just use the rest of the formula. So the natural log is equal to 1. Here, look at my formula. Is times, actually. I got to go up and look at my formula there a minute. Hang on, I'm going to pause. Well, if we look at the formula up above, okay, the way it works is go down, about halfway, and it says, next we take the natural log of both sides, and so in this case the natural log, which we've done, is equal to 1 over, it's a negative, I'm sorry, negative 1 over 60 in our case, because 60 is our mean. They've got 4,000 for their mean in their example, times x, and x, of course, being what we're looking for. So in our case, it's going to equal, the natural log is going to be equal to 1 over, minus 1 over 60x. Okay. Well, what can we do then to equalize both sides is we multiply each side by a negative 60, right, by the mean. Okay, and that should solve us for x, and so this is simply equal to our natural log times negative 60, our mean, and we come up with then a median of 41.5888. That kind of makes sense. If our mean is 60, this is relatively close. Half would be faster and half would be slower than that. Relatively close to the mean, not that it always is. So there you have it. Again, a little bit gnarly, and the last question would probably be listed as extra credit or bonus.